Welcome to the Railway Civil Engineers Association. I'm Jonathan Butchery, I'm the chair of the association. We're an affiliated society of the ICE. We basically arrange rail stuff for the ICE. Last couple of years obviously been a bit weird. We've had lots of hybrid meetings, lots of online meetings. We're just starting to get back to in-person meetings. What we try and do is arrange talks on really interesting projects that can help you learn more about stuff going on in the industry, really things that will be of interest to you. It's the first time we've been back in Birmingham, so I think about 3 years ago. We had Sir Peter Henry, actually in the actual town hall, I think, possibly for a meeting. So it's great to be here in person. So again, a big thanks to WSP for providing the office for us. We have the first slide, please. I'll get my notes as well. So I'm going to talk about the reconstruction of Birmingham University Station tonight. We've got George Smith, section engineer with VolkerFitzpatrick, and Sean Darren couldn't actually make it, so we've got Michael Gardner, who's the engineering manager for VolkerFitzpatrick, who's going to talk to us about that, and Edward Carstairs from Mott Macdonald, the designer. Sometime in the last century, I stepped on a train at Birmingham University Station and went for my interview in the School of Civil Engineering, where I went on to do my degree in civil engineering, and somehow I ended up working in the railway. I remember the station, good late 1970s London Midland region design station. And worked very well for many years. But as the team here will tell you, the passenger numbers now are something like tenfold what they were when it was designed. I think it was designed, I read something like 250,000 passengers a year, and in recent years it's been serving 4 million. Birmingham University and the Queen Elizabeth Hospital become major destinations in their own right. They're like a small town. And I think I don't know whether people always appreciate that, really. You just think it's one station on a line. And it's a station that didn't exist until the 1970s. But an incredible amount of journeys are generated by that region. And it's a really good thing that people are travelling on an electric train, not driving on their cars or having to use other forms of transport. So, the team here are going to talk to you about why they have to expand the station, what we're doing, and believe me, those photos don't do it justice. It's much, much bigger than that. So this is a fantastic project, but effectively a small town within a city, maybe not even small, that will improve the environment, improve travel, and really, it fits in with a lot of what we're all about at the moment in terms of climate change and pollution. So really looking forward to a good talk there. Just go on to the next slide. Just to let you know, next month we'll be having a talk on the upgrade of Gosforth train care facilities, Tyne and Wear Metro. So we're just finalising the details of that, so look out for that. All our events, you can find them on the IC webpage, ICE events, or you can look on our website, rca.org.uk. Just nip to the next slide again. And that's membership. We're not particularly expensive, £18.50 for the year for ordinary members, £8.75 for young professionals, graduates, £5.50 for retired and free for students. Join us, you get mail shots about events and talks. Now that things are starting to normalise, we're looking to arrange site visits again. So this afternoon I have the privilege of walking around the site of the university station. We'll be doing more things like that. So if you're a civil engineering working in the rail industry, do join. We've got a really broad and varied membership, and we try and put on really good events and talks, and it's all good part of your CPD. So I think without further ado, if it's all right, I'm going to hand over to Ed, and if it's all right, Ed, if you don't mind introducing yourself. Yeah. Thanks.
Thank you. Hello everyone. So Johnson said, I'm Ed Carstairs, one of the civil engineers with Mott Macdonald. As one of the designers, quite heavily involved with a lot of the development, detailed design on the station. So me, myself, Michael and George, just going to try and cover what we can really in a relatively short space of time we've got for the scale of project it is. So moving on to what we've got on the agenda here. So this is just a breakdown of really between the three of us. So myself, I'm going to just take you through some of the design and coordination aspects. Michael's going to follow up with some of the constraints and constructability side, and then finally with George, just looking at some of the delivery and construction of this. So then again, just a little breakdown of just what I'm going to take you through really. So I'm going to start just a little bit of, Jonathan's already spoke a little bit about this, but a little bit of overview and background to the project. We'll move into just some of the stakeholder engagement that we went through at the sort of earlier stages, how that led into developing some of the objectives of the scheme. We'll move into just looking at some of the constraints of the site and the opportunities that we had there, and then following on through the concept development, and then finally some of the detailed design delivery that we had. So just to start off with, this is just to give an overview for any of us that sort of weren't sure where this was. So this is the West Midlands network map. You can see I've just highlighted there just where we're looking at for University Station. So it's on the Cross City line, just a couple of stations south from New Street, as you can see in the centre there. And it's just to give an impression of where we are on that wider network. Just move on to the next slide. And this is just going to give us just a nice video sort of introduction as to where, hopefully, if this this wants to play. Just as where this is geographically, really. So we'll just see sort of, as I've spoke about, where it is. As the name suggests, it's right next to the University of Birmingham campus, right on the rail, which is running parallel to the Worcester-Birmingham Canal in this area. On one side of that canal, you've got the university campus, and then directly on the opposite side of that canal, you've also got the Queen Elizabeth Hospital, and this is just sort of showing some of the key features, just showing final proposed building that we're eventually going to get to, really. Yeah, if you can move on to the next slide, please. So just a little bit about the existing station. As Jonathan spoke about, this was originally opened in 1978. It's comprised of two platforms, and these have fairly limited canopy cover at the moment on both sides. You can sort of see it from that left-hand image there. So there are some sort of wider sections of the canopy, and it moves into sort of a thinner section on one of the platforms, and doesn't really cover much of where you could be stood on there. And it's quite a modest sized building, as you can see there, with one access on the road below, and it was originally catered to 400,000 passengers, you can see there, and then the current estimates roughly something just over 3 million passengers a year we're having this, so it was in need of some development. So this is just an overview of the scheme and the proposals that we have here. So working with the client at the West Midlands Combined Authority, with the detailed design, VolkerFitzpatrick as the principal contractor, appointing Mott Macdonald, the lead designer, and associated architects as the lead architect on this. So as you can see there, this is just an overview of the station. So you can see at the very bottom of your screen the existing station building that we just covered the slide before. So the new proposals we're going to be covering today. We've got two new pavilion buildings north of the station. We've increased the canopy coverage right the way along both platforms, so that there's now full cover on the entire length. We've also got connectivity between the two buildings, where there's a rail link bridge there, and we've got, you can see to the right hand side of your screen, a bridge that leads over the canal and to the university campus. And then we've also got some more sort of extensive forecourt works, as you can sort of see in the bottom left hand corner, and there's some smaller ones just a little bit nearer to the university campus at that canal bridge side. So if we can just move on, we're just going to, on the next few slides, it's just going to take us through sort of how we went from that sort of early stage sort of option selection through to concept design. So this is just to give an impression of some of the key stakeholders that we worked with at an early stage. And I think the real big takeaway from this was on the amount of different requirements and different sort of some similar requirements as well between those, and having lots of workshops, lots of interactions with those to try and really produce something that would fulfill try and fulfill that for each of these stakeholders, and how we could work to try and make something that achieve that vision. So if we just hop onto the next slide. So out of all these discussions and a lot of these meetings and things, we ended up with this sort of, I guess you could call it a mission statement really for the project. That was to deliver a flagship railway station that is welcoming, safe, and heralds a gateway to a world-class life science, hospitals, and university campus, whilst providing an outstanding passenger experience, boosting the economy, enhancing the heritage, and connecting seamlessly into a wider integrated transport network. Now, it's quite a big statement, and that's why, sort of, as you can see on there, we tried to really pick out some of those key things from that, and from that sort of big wider vision of something with sort of aspiration to hit. Then taken it and we've really focused on some of these key objectives that we could look at for a concept and look at delivering for the design and eventual opening of this station. So if you just click on to the next one, so these are the three key sort of scheme objectives that we came up with. So you can see number one there is obviously the key one that we've already spoken about, and that's in terms of increasing the capacity. Like we said, we're already exceeding, the existing station was already exceeding the numbers that they were getting in footfall every year. And then that's expected to, some of the forecasts show that that's expected over 100% increase over the next 20 years. So we really want to make sure that we've got something that's not only catering, but now obviously making sure that we future-proof this. The second one is enhancing facilities. This is quite a broad spectrum of things we're trying to fit into here and we're trying to look at. So there's a lot about it, trying to improve that passenger experience into this station. One of the key things that Jonathan mentioned is that we are at Birmingham Station is quite unique on the network, but it doesn't aim to just feed everyone into Birmingham. It's actually a destination. So we're really looking to try and capitalise on that, make sure we're enhancing some of the heritage around, which we'll speak on a little bit, and make sure that we're really making improving that access for the station, really looking for that access for all was a real key driver for us throughout the design. And then finally is improving connectivity, key one really here, and that's looking sort of locally at the station itself, so trying to link the campus, Birmingham campus, across to the hospital, but then also making sure that we're sort of trying to integrate this onto the wider network. So these are three things that we're going to try and you'll see constantly trying to sort of feed back into related. So this is just a map of the site. We had this before. You can sort of see the proposed development here, and imposed over the top here, we've got just some of the key constraints and opportunities that we looked at when we were developing the concept for this. So you can see straight through the middle there in the red, the fairly obvious sort of thing to work around is that we're going to be constructing this the whole time whilst the rails remaining operational. So that was both obviously a lot of construction constraints there, but we really tried to work through in the design what we could do, sort of methods we could introduce, things we could do in the design to try and really limit sort of methods of working in here and seeing what we could try and do. In the big sort of blue corridor that you can see to the right of that there is just sort of highlighting that canal corridor. So that's sort of including the canal itself, the embankment, all the vegetation around there. So really trying to think about not only how we can construct around this, how can we look to really enhance that canal frontage. There's still going to be a tow path just next to the building that you can see was still open whilst we were doing construction, how we can work around that. On the left-hand side is an existing blue route that I've highlighted in purple to confuse everyone a little bit. And this is just because we're next to a running hospital on the left-hand side there. So blue route just means that it's one of those things where potentially for construction further down the line, it's a little bit more difficult for some of your usual methods of being able to have partial road closures. Just something to consider in there with the design. And then finally, as you can see in the yellow, it's just a representation of the area most affected by some of the underlying archaeology on our site, which we'll just get to on the next slide. So with this, you can see on the left is just an opposed image really of the archaeology on the site, and I've sort of highlighted in red the area of our sites, the area this is influencing. So this is actually a scheduled ancient monument below the sites. This is an old, it's called Metchley Fort, it's an old Roman fort. And you can see that our site is sort of on those two white lines as the eastern annex. So those two white lines that run through there are highlighting some old fault lines, some old the barricade lines on those, and run sort of diagonally through the entire site. And then you can't make it out too well on the screen, but just sort of from the centre coming back out towards those is what's believed to be the alignment of an old Roman road as well. And this is something else that comes directly through site. It's really had a big lot of engagement with Historic England on this, and had a big driver in a lot of things we tried to do in the design and for the construction, and how we could work through the consents of that. And the image on the right is really just to give some perspective. Again, going back to the stakeholders that we had a few slides ago, it's just to give a perspective of the different and quite complex ownerships that we have just in this one site, and just showing the interfaces with all those. It's quite an interesting project, and an interesting thing to manage around all the different ownerships, different stakeholders, and how we could manage the design of that and how we actually delivered that. So we can just move on. And so this just thinking about some of those the requirements that we had, the objectives that we had, and the constraints and opportunities we had. This was then sort of the next logical step, and working alongside associated architects on this at sort of a much earlier stage and closely. This is sort of the process that this went through for some of this development. So you can see on the left there, as we've just discussed, about the fault lines. It's quite a key driver into where we actually not only located the building, so the mass of the building was moved to have the least impact on that. So that's why it was a bit odd when you maybe first see it, you wonder why the station's so far from where the original was. So it really pushed the mass further north. And then from that mass, the actual sizing of it, when you think about design, is sort of governed a lot by the numbers we're expecting, the sort of pedestrian flows, the widths of the stairs, these sorts of things to try and get that mass size. And you can see then in sort of terms of the architectural vision on this, trying to really trying to have that frontage that aligns with these fault lines. The mass was then sort of elevated, and then creating that link from the university campus across through the station to the opposite side. So we're actually thinking about trying to create a new link there that eliminates the need to sort of this old route that you would have like sort of right around all the roads. It's a much longer route, whilst trying to make sure that we had a route there that was always open. There's no need to interface with any ticket gate lines there or anything like that. It's just a route that will be right the way through. So it really hits on that third objective that we had earlier on. And then you can see on this middle of bottom one, then just showing how the sort of landscaping design was really catered around all that. Again, all that underlying archaeology, and it was looking at enhancing the heritage that we talked about a little bit earlier on, trying to enhance the facilities. It's one of those drivers for that. And again, that then led us on to the final concept. We've done nicely to the next slide. This is just to give really just an impression of, so from that final concept design, and we did a lot of this. It was just I think a bit of a success story in terms of that early engagement, early management, modelling things early. That we got something to a point where we had these visuals at a concept design. And actually, when sort of the top line is all the ones, the visuals, the vision we had it as a concept, and then moving through to the final sort of models, some of the latest ones at detailed design. And it's just to show, I think, that how you can get these things done early, get buy-in on this. Can be quite successful in what we can deliver. I think that's something we did well. So then finally, just a little moving on, a bit of a few points on the actual detailed design delivery moving through. So we're just going to really just look at three key areas for us here. Just a little bit on some of the health and safety, some of the safe by design, a bit on some of delivery, some of the delivery methods we used, and then hopefully just linking into some of the sort of more modern methods that we try to incorporate. Just on to the next slide. So this is just a couple of examples of some of the health and safety, some of the safe by design things that we did within the detailed design. This is really important to us in trying to, as much as we can eliminate in this sort of digital world that a lot of these, these things are starting off in now, as much as we could eliminate as designers at this point, to remove any of the, mitigate all the risk to these guys when they're going out and sort of developing all the stuff on site. So the left-hand images is just to show. So this is a layout, the pile layout of the Pavilion 1 building, and what we had due to program, quite a tight program we had on this, and I think Michael's going to talk you through some of the things on that. But it's in terms of the program, what we needed to hit some key dates for possessions on this. So what we actually had, this red hatch line that you can see come through here, is actually a buffer zone that we put in, which represents I think it was a metre wide buffer zone we had either side of an existing high voltage cable, which ran behind one of the platforms. And to meet these deadlines, we actually redesigned the piling locations, the pile caps, to enable these to be installed prior to that cable actually needing to be moved. The idea was to try and make sure that we could hit these key dates. I think that's something key that we'll come on to a little bit later. The right-hand images, and just another thing, we did a lot of work on sort of the signal sighting through the station. It was due to the curvature of the track through the existing university station, and it's actually quite a key thing, this signal. It's actually one of the more difficult stations for the drivers as they come through here. And so we wanted to make sure that as designers and before we got to actually putting things in on site, we can do these desktop assessments and make sure if we can look at something now in the sort of digital space and have confidence that that's going to work, sort of really mitigates that any of these costly things that could happen, all of these health and safety risks. And that's not in just bottom one, just sort of shows an obvious sort of final infrastructure, but then we could also do some ones looking at lighting, temporary works. So it's really looking at all of those stages. Yeah, move on. So the next little bit is just to really highlight, again, on any sort of big, large project like this, we have a lot of, and this is just a sort of a handful on the left of some of the interfacing organisations. It's by no means an extensive list on that. And same goes for this right-hand part of all the sort of disciplines that we have that are interfacing. And this is, I guess, how do we manage this and how do we look at it? So you can just move on to the next slide, please. So one of the key ways, I think one of the key things we did, as I've sort of already alluded to on the project, we had a lot of using a lot of the sort of BIM methods and a lot of 3D modelling that we could do, so we could really utilise on the project with all the different disciplines being able to come together. We look at that continuous design review, and it's something that, and you'll see from how we actually were delivering this and what the program was. So, for example, in that bottom right-hand image, you can see there, this was just something by being able to model these in the digital world, being able to do this, we have confidence in some of the precast elements. That before this went into manufacture, we're having confidence that these things are going to be able to fit, these things are going to be able to work. It's just one example, really, of the success that we managed to have on the project. I think it's a good thing to highlight. And then finally, sort of following on for that, it's going to lead us into some of the construction methods we used, was just how we utilise some of the modern methods of construction. So something you may or may not be particularly aware of, but it's now more of a push to try and have as many things sort of manufactured off-site as we can to avoid any prolongated site works or any health and safety risks for these. We can try and reduce the cost. We can try and hit more deadlines in the program. Sort of 3 key areas that we hit this on the project. Number 3 in there is looking at those sort of the assembly of structures. So having structures that we can assemble and have repetition. So a big example of this will be that George is going to speak a bit about is the precast structure and how we went about implementing that on the project. We use this for canopies as well, how these were brought in sections. And then number 6 would be sort of more sub-assemblies and things. So we have this, for example, in the cladding used on the station. And then number 7 is more some of those site process innovations that these guys talked to you a little bit about. And the final slide for myself is just showing a few of what I just described to you. So we will go into a little bit more detail, and I want to hand you over to Michael and George to take you through the next part. Thank you.
personnel. So I've got lots of notes. My colleague will stand in front of you. There we go. Through what we're going to talk about then. So we're going to look at the project organisation structure. You all read, but I'll read for you. We've got the key health and safety and operation risks, introduction to TDRA, which I'll tell you what that is in a minute. Progressive assurance and quality modelling, twin programme modelling. Let's start the slide, please. Thank you. So Ed's already mentioned that there's a vast amount of stakeholders involved in this project. The main stakeholders, again, one would be NHS. Within the station facility, we are constructing an office or a space for the NHS to offer some sort of medical facility. What that is, we don't know. We've just been asked to provide them with a space. The university itself, when you look at the structure and you look at the location it's in and the buildings around, you can see it does match in quite nicely. There's been quite an influence from what's its environment around itself. Public transport, obviously, very involved. And in the pocket, they're paying for a brand new station to be handed over to Network Rail. And Birmingham City Council. There's roads adjacent to the site, which we're trying. You go over to the ASPRO team. ASPRO standing for Asset Protection and so what that means is we're building a facility which will be owned by Network Rail, and they obviously want it to be up to their standards, and they also want a facility which they maintain. So they review everything which we put on the ground, sign it off, to make sure that we're achieving what they're looking for. SLC Rail, they are supporting Birmingham University, taking their reviews upon and making sure that they're getting A1 from their standards, their expectations. Principal designer, that's us, VolkerFitzpatrick. The lead designer, Mott Macdonald, supported by architects, associated architects, and Node soft landscape. Once Mott's put together the concept design, it's fleshed out by our specialist suppliers, Alicraft, Fourways, Shea Murtagh and Van Els. Alicraft are doing the planning details for us, internal and external. Fourways are our MEP designers. Shea Murtagh are doing precast for columns, for the main structure itself and external landscaping. Van Els assisted, giving us the best possible design for the pilot based on the techniques and the loads which we require. Subcontractors, again, we haven't listed them all. They're Oliver Connells, our main civil subcontractor. Millers, again, they are our installer and fabricator of steel work on site. Contract value awarded at 36 million. It's a design and build. It's an NEC for students who are taking notes. Next slide. So health and safety issues.
We just had a request. Could we try and make the sound a bit clearer? And maybe you can speak up perhaps a little bit.
Okay, I'll try. When I was issued these slides, I did question that the hours worked, and I was right to. That is for a quarter. We present our hours on a quarterly basis. We've been working on site since August 2020. So we're looking around at more at the 800,000. As you can see, lost time incidents or accidents is currently 0. A lost time accident, anybody has to be away from the place before the sector. We've had 1 minor incident or accident on site, and the number of personnel working in a single shift on projects has peaked at hundreds, considering the size of the actual job.
Right, if you mind coming over here and speaking so they can hear us a little bit better, I think.
That is pretty impressive.
Yes.
Is it worth?
I mean, you could give the talk from here if you want, or I can put this a little bit closer. Right, I'm not quite sure what that's done to the camera, but it's thank you. Sorry to break the flow.
Again, what Ed alluded to is the constraints which we are working in. The main one being the rail corridor. It's a 7-day-a-week operational railway with the 25,000 volt cables above, which you cannot get. We work within 2.75 meters of. I think what else. Just trying to think why you put this slide. So the constraint is to be able to work in and around the railway area. There are certain windows and areas you can work in without affecting the general public or the operational railway. If you do affect the operational railway by putting a crane or working, putting a machine adjacent to the track, then you have to take something called a possession or an isolation, which is literally you're stopping trains from running and you're switching off that power. Now, Network Rail will allow you to do that, but you do have to book that in advance. You're looking at booking anything which is outside of their normal work hours, 18 months out. So when this job was first programmed, Network Rail allocated 7 outside sessions. Next slide. Not only do we've got the railway, the canal obviously is the easiest places to work. One of them being the people who actually run it. We're very, very precious about the canal. CRT, Canals and Rivers Trust. They don't like going anywhere. So whatever you do, you've got to get accepted, method statements approved, and if you wanted to, for instance, if you wanted to close out a tow path, again, it's 8 weeks, 10 weeks out to allow you to even think about closing it. We were reasonably lucky because there is a diversion which takes people around the back of the unit. It's not too far. So, but we did need to close it, obviously, when we started putting craneage over the canals, and when we installed this bridge. I don't know if you picked up on the fact that within the areas we're working with, there's a platform 2, pavilion 2, and that is constrained with the railway on one side and the canal on the other. So it's an island area which has no road access to it. So the only way you can get anything in there is either when the railway is closed, so you can drive across the railway, you have a thing called access point, which is like a rubber mat to allow you to drive over the tracks, or it's crane. Those are the only 2 options. If you use the wrap, you're restricted by weight. They might be putting too heavy over their tracks, and also you've still got your overhead line above you, so you're a little bit constrained on the height of any vehicle which goes through there. One of the things we had to do to construct Pavilion 2 was to transport around about 2,500 cube of concrete to that platform. Now, to crane 2,500 cube of concrete. So we come up with a novel. It hasn't been used, we're aware of, anywhere else on the railway network. We put a pipeline through the track. It's not underneath the track, it's through the track, so it actually goes between the sleepers. The reason for that is if you go underneath the sleepers, it will affect the support of the track. There's a lot more to consider. By putting it through in between the sleepers, one, it gave us good access, good maintainability of the system, and it allowed us to pump concrete, which was around about 160 litres. So again, the pump mixes which we had to use had to be designed. We did a lot more testing cubes for the concrete which we put in the ground to make sure that we were still achieving the right quality. You see, we've got two pipelines. Again, if one gets blocked, we still got availability to pump concrete in the other one. But once you start a pour, you really finish it. Okay. Right, so this is just to give you a little bit of a flavour of what we did as a business to win the jobs. This is our tender programme, tender methodology. As George gets involved and shows you some of his slides, you'll see that it's slightly different. But it just gives you an idea that the original concept was to use one of the largest cranes in Europe. These are 1,200 tonner, positioned in the university grounds and lifting everything across, supplying these small spider cranes and track cranes or crawler cranes. Centre there. Needed to be a big crane because we needed to lift the crawler crane in the first place and then lift it out. You've also noticed there's quite a substantial amount of temporary works. Again, could only be installed during possession, and those possessions, like I say, were fixed in stone 18 months out. So, so easy, isn't it? Again, the station itself is on 3 floors. A bridge in between. A bridge which leads directly into the university campus. So you can actually walk through the station without what it is for the general public to view. It's good to have these animations and stuff. Right, next slide. Right, as I previously mentioned, 18 months before this job was let, possessions had been booked, and therefore we had to hit those. If we did, the whole project would then slip 18 months. To meet those deadlines, really, sorry, I'm watching the way. To meet those deadlines, we needed to achieve design. We picked up the project at grip stage 5, detailed designs with the concept is there. We knew what we were going to build. We were going to build 2 pavilions with the bridge across, etc., etc. But to try to meet these deadlines, we adopted something called progressive assurance. Progressive assurance gives the opportunity, everybody buys into it, all the stakeholders, the ability to start the fabrication process for items such as precast concrete. Precast concrete is on around about 20 weeks delivery. Glazing is on around about 24 weeks delivery.
So you need to get your orders in quickly, otherwise you'll end up approving your design and then start the clock for your manufacture. That would have kicked our program right out of the ballpark. So we had to get people to agree that we reached a certain stage within the design. Everybody was comfortable, everything was coordinated to allow us to press the button on manufacture, but still undertaking the process of completing the assurance process for the design. And that's what progressive assurance is. Next slide. I missed a slide. I thought there was another one. Might be the next. Clause 31. So sorry, there was 7 elements to progressive assurance which we identified, which we needed to achieve to meet the possessions: piling, precast, cladding, the link bridge itself, which is the bridge spanning over the railway, the canal bridge, again because the access we needed to allow other works to go afterwards, the glazing. Now, I've given 3 dates there. One is, sorry, 3 items. Clause 31, which is the construction programme which we submitted to the client, which everybody signed up to. The October one, you can see there's slippage, and then November, again, you can see more slippage. Now, the reason for that was to do with this, I thought it was the other way around, it's TVRA. It's to be taken out. Ah, that's why. Throwing me, okay. So the TVRA. I don't see that.
Just keeping an eye on the time. It's 6:45.
All right.
So
it's to do with terrorist mitigation. So during the GRIP 4 stage, it was identified that the TVRA had not been undertaken, and therefore it came about quite late in the project. The category for the station at GRIP 4 or at AIP concept design was a Class C station. Following the submission of the TVRA, it was identified as being a Class B station, and therefore it was a lot more severe when it came to the loading criteria for things like cladding, the actual the frame of the building, foundations, and that's what kicked the program out. You have thrown me by taking that slide. Sorry. That's it. Next slide. Yeah. So 4D modelling. So progressive assurance. As I said, you've got to get all the main players involved. You've got to get their buy-in. You can achieve what everybody's confident and is comfortable that we are going to build something which can be built to a time scale. So the way we did that, 4D modelling, again, it's 3D plus time. So I believe the next one's an animation. Yeah. So you can link your 3-dimensional model to the Clause 31 program, or sorry, Clause 32 program, which is the construction program. Yeah, this is just demonstrating how the software runs it. And when we go on to the next slide, see, so the Clause 31 is the contract program. Clause 32 is the actual program you're working to. And then we have what we call the what ifs. So the what ifs, you can resequence the works to see how one certain element, perhaps you might do the roof on Pavilion 2 ahead of Pavilion 1, and it gives you the end date. Yeah. Now to the interesting bit, okay? George.
Running out of time, actually.
We're slightly over, but yeah, be about 10 to 15 minutes.
Yeah, that's actually fine. So just quickly going to go over bridge installation, precast concrete, structural installation, the system we use for precast concrete, how we work during possession and in possession, and then just some construction challenges. So if we go to the next slide, so the first one, the most exciting part, bridges. So one on the left, this is a link bridge. So you saw the tender slide on the that little animation. They put the entire bridge in as once and had to get that absolutely ginormous crane. So this is still an exceptionally big crane, a 500-ton crane lifting in 2 girders, and these came in separately in 2 pieces. You had to bolt them together. They ended up, so with a 26 metre section, 10 metre section, bolt the 2 together, ended up weighing 34 ton, and then you have to lift both girders in, put 19 cross-linking beams in. So that was a fun day for all us site engineers. It's quite a nice little thing for us to do. But the big challenge was this. This was the canal, the link bridge. So link bridge spanned Pavilion 1, Pavilion 2, and we had to lift it in over an 8-hour possession with the whole bridge prefabricated. So it came just as a steel frame. We put the curtain walling on, the glazing in, we put the upstands on, we waterproofed it, and then just lifted it all in one go. So that ended up coming in, I think it was like 48 ton, lifted in with a 500 crane. Again, if you remember the tender video, this was lifted from the other side, across the canal, across P2, and then in. I don't know why we did that. Instead, we went into the NHS car park, luckily, another 500 crane, popped this in, and it was another really challenging day for us on site. There's actually only 80 mil tolerance either side of the bridge, either side of the building. So we were trying to get this about 20 metre structure narrowly in spaces. keep away from each other to make it as safe as possible, chase each other away. And then that's how we worked out to what dates at what times, so we can make all these key possession dates. Like we said, you can't just bring up an SOL and say, oh, so it was a really good bit of software that we used to make sure that we did everything, got everything installed in the right time. Let's get to the next one. Try and take a bit of time. So to do this, we had to be as efficient as possible, and the system we used was the Pico system of installation. So unlike what you normally see of holding down bolts that come with a cone and you cast ground, so these actually just we fixed them in place, and then they gave the bending moment. So this meant that we didn't need as many props. So as you saw in the tender video, we had loads of props either side, and these all had to also be installed in possession. With this system, any propping we had to do was only to plumb columns. So it meant that we sped up a lot quicker. Also, you can see during the installation in this video, so it comes with a beam running across the top. So this is the Pico lift. It's part of the installation process. And what it means is that there's a bar in the columns, and the columns obviously come flat on the truck. And then you take it off and stood up. And then with that, it allows us to just pop this bar in, stands them up, and a lot easier to move, a lot easier for the guys on site to actually get into the right place and get them installed. So that's the next slide, Ed. This is a few pictures of the cranes working using them. So this is the 300-ton crane that sits in the NHS car park. Just using, you can see the bar runs across the top. It just makes it a lot more simple, a lot faster. And then here you've just got some of the props that are meant just to plumb them, what they're not, to keep it structurally supported. So it's a really nice way of being as efficient as possible in those really short windows of working. And yeah, like I said, 540 pieces of installations, precast installed over 220-hour possessions is really a good testament to the guys on site. And then the next slide we're looking at is how we try to increase the amount of time we could work with the cranes and do it install. And with this, it's a thing called Any Line Open. So Any Line Open is a system of working so that you can work close to the railway, but without the railway being closed. So when you do this with lifting the cranes, you use a thing called combined collapse radius. So combined collapse radius is if the boom was to fail. So for example, this crane, the boom was to snap and it fall down, whatever you're lifting is also going to be the worst case scenario if it was to lay down in front of it as well. And then that whole distance needs to stay 4 meters from any network rail infrastructure. So that means OLE, stanchions, return conductors, those kind of things. Anything to do with the railway, you need to keep 4 meters clear of. So as you can see, that takes quite a large portion of our building out. So we could install this upper level, but besides that, everything had to be in possession. So just making sure that we worked out the maximum amount we could install, make sure the crane was in the perfect position to just maximize the amount of time that we didn't need possessions really had benefited us. And this is something that looking into using 4D modeling, being able to position cranes and work out these kind of things really was the backbone of how we got all of these bits of the install done in time. So with this in mind, we're trying to work out what's the best way to work near a railway as safely as possible, but as efficiently as possible. So we have to try and think of innovative ways to do this. One of which was build a scaffold which had a monorail system. So this rail, as you can see here on the drawing, and then actually in practice here, allowed us to take all the cladding on the railway elevations, all the glazing up and install without using any cranes or anything like that. It's just a winch system. It was lowered into the lifting well, the winch lifted up, and then it could just be taken across either elevation. So again, this was such a great way for us to allow us to work and not be in trying to lift over a building in between in between cables and your structure with a blind lift is quite a dangerous, challenging thing to do. So this is a lot safer, more effective, more efficient way of doing it, and it's such a simple option, but it's something that was it's quite easy to overlook. So I was really pleased that this worked really well and managed to get all these rail elevations done in a really quick time, which is a really nice bit of engineering for us. So now the project is going to be handed over in 2 stages. So stage 1 is going to be just what you can see highlighted. So everything in colour, that's going to be part of our stage 1 design. stage 1 handover from the Commonwealth Games. This is canopies, platforms, lighting on canopies, and then the speaker system. And then all of this is what we call the University of Birmingham forecourt area. So this will all be ready, all handed over, and then once this is done and the Commonwealth Games area will come finish for stage 2. And this will include the stairs, the ramp system, the canal bridge, and all the rest of the actual building itself. So yeah, this is still very, very challenging dates for us to hit, and it was key that we hit all those key 7 possession dates. And finally, just looking over some, as a site engineer, lessons learned that we've got. So 3D and 4D modelling has been completely the backbone of what we do. The 3D model that we use on site will be opened by every engineer every day. So we use the 3D model for things that you can think of: clash detection, making sure that the people you're telling instructors to do stuff on site, but they're not going to then a week later have to be taking it down for another trade to be coming and doing something like that. Or just thinking about your actual sequence of works, how you should be doing things. And this was what made 4D modelling great. So we can put a program together and then actually in 4D modelling build the job in sequence and realise, oh, actually, if I build this, I can't get here and I won't be able to access that afterwards. So with those two things in mind, you can really start to paint a picture of what the project's going to look like and how the best way to go about building the structure you're trying to get around. And for us, this has just been fundamental. As well as the 3D modelling, there is, like I said, non-possession working. For us to be able to do as much work as possible without being granted possessions has been one of the key things for us. Looking at the models and making sure that we can work where we can work and not work with requiring possessions. I can't reiterate enough. It's been really good for us to plan what we can do. And then finally, one thing for site engineers is because we're building into it, we reduce the ground around us. It was quite challenging to actually get to work out your line level and coordination, because what will happen is as you start to step down, you start to lose accuracy because you're transferring things again and again and again. And what we found was once we've got in and there's other subcontractors, engineers all doing their own things, we started to lose accuracy. And the solution for this was, we're in a built-up area. We mounted high up prisms. We traversed all these in together, and it meant that everyone on site was all singing off the same hymn sheet. We all used the same control, and it all pulled that line and level together. And that's what allowed us to do things like get the bridge in such a neat little position, and just make sure all those 3mm accuracy things was done perfectly. And just realizing that early on, that the issues that we were going to come up against if we didn't rectify this. And yeah, as far as this project goes, for me and all the other site engineers, it's been a really exciting, really fun job for us. But that's all I can say about the University Station Birmingham. Thank you very much for listening.
So I try and seamlessly right over here. We'll take some questions and answers. Thank you very much, George, Michael, and Ed, for some really fascinating talks. And if people online want to post any questions, I'm not seeing any at the moment. But yeah, any questions from you want to say who you are and by all means introduce yourself.
My name is Richard Brown, father. Didn't really know much about pedestrian from space. Knowing that area extremely well. Pedestrians going from 15 stations to very quite a long way for constantly back and forth. Firstly, station of 9 stations the whole station much further out away from did I understand that the main station will be open for Commonwealth Games?
Just for the benefit of the remote attendees, this question there about the pedestrian flows. It's a very busy area with a lot of pedestrian movement from the hospital and the other areas to the university, and how that's affected by the design, and also a question about the opening date. So I don't know who wants to answer that.
So regarding the road, there's nothing within our scope It's already across there.
Yeah, no, I know, but it's possibly pretty well used.
Yes.
Go down there, more than possible, but how is it possible? Let's be quite patient. Also, it does actually wait for how you change the access to the station, I suggest the risk of being actually increased. As you can tell now, the because your path is critical.
Again, that's not part of our document.
Is it?
I can't really comment.
I think that's not. I'm an engineer.
Yeah, I think there was something when we did look at this in the past. So there's actually provision near to where we've got a drop-off area. Actually, so there's something that's discussed, and there's actually some future. There's something in when we looked at the concept design. It's something that was discussed as an option, and I think to put in there's an additional crossing. If I'm right, it's just we've got a big on one of the pictures you saw before. We've got sort of the main Birmingham forecourt area, and then there's a big drop-off area that we've got running to the side. And obviously, I see the point you're trying to make is that the crossing is much further down near the opposite side. So it's something that's not being implemented at the moment, but it is something that is considered up that just near that drop-off area. There's a corridor there where there is provision for a potential future crossing there, and has been discussed. And it has been discussed with.
So, Ed, would pet flow modelling have been done by the stakeholders, by the people doing the master plan, the university? Would they have considered that as part of their?
We did have a pet flow model. I can't remember the.
So it's from the associated context. We've got a shuttle bus. City council is on the master plan. All the back towards.
So pet flow modelling was done.
The background thing.
About opening for the Commonwealth Games, which bits would be opening?
So the new station will not be open to the Commonwealth. Only part of the station we're looking for is on platform wide. Platform. Yes. Platform is literally doubled in size. They have existing entrance. It will become an exit only.
No, during the Commonwealth Games, how will the pedestrians go in and out of the station?
There's going to be a stacking system by the station.
Current station bridge, the only entrance is
Correct.
Yes, that will be the low road.
Yes.
But you will have a wider platform, so we will.
Yes.
So it's something to group it, because it's as a designer, you often don't appreciate just how narrow 2.5 metre wide platforms are, which are fully compliant, but that space gets used up. So at least you'll have the widening in place. So, do we have any other questions from the audience, then, please? Chris.
How much the boarding model?
Precast.
What's the recording?
For the precast itself, I'm pretty sure it's spot on.
Yeah.
The actual installation of the precast.
But every possession we work, the programmed installation, there was one weekend where we were maybe 5 pieces short, and the only reason that was because they hadn't been delivered, they hadn't been manufactured. We were so close to the manufacture to the install, they would be boarding in Ireland, shipped across to Liverpool,
and then driven to site. Concrete had gone off by that time, and they were lifted up. And it was hand to mouth.
Yeah, it was a pretty impressive sequence there with the Jenga pieces with the concrete being lifted in. I appreciate that. We have another question. So first from the back and then second one.
Hi, Dennis University. Obviously, the client was West Mid Railways, not Network Rail. So what challenges did you face on that? And you found?
To be honest, they're very good. They're very proactive. They want to see the station there. And so did the university.
Was that West Midlands or Network Rail?
Network Rail, again, on Network Rail. I won't say anymore. But no, I say that there is a real desire to improve the connectivity. They are the right organisation for that. They are very proactive.
Okay, there's a question just in front.
I was just wondering about health and sustainability of the design, really the efficiencies of things.
Yeah, so I do know in terms of, I know that we're aiming for, I think it's a BREEAM very good rating in terms of the design. I know that we've had a lot of work with, we've got a lot of our, we engage a lot of our ecology teams in the office and a lot of the sort of wider disciplines on these things. It's sort of hard for me to come with exact specifics on these, but we do, there's a lot of consideration that is going behind this and sort of the, all the sort of everything from our devote plans that we do to anything that we need to add in there to the types of methods we are using for that construction, as we sort of touched on a little bit earlier. But it is something that has some that's at the forefront for us really. When we're looking at these things, and we do engage, we have teams from that within the organisation that we do work very closely with and have them throughout.
Questions, please, Steve.
Network Rail.
The audience.
Yeah, couple of questions. One, in terms of the existing entrance, is I'm assuming that once the project's finished, that will be retained. And have you got any works planned to upgrade that?
Again, the original scope was to remove the existing ticket office and turn it into a number of retail units. But that work has been scoped. We are doing a little bit of refurbishment works, changing the wiring, the lighting. But other than that, hopefully somebody will come up and finish the project. Place around spanking new amphitheatre of the station with a shack work at the end, which is a shame.
You've got to resist anybody telling you to take that bridge down because we're being hit with our problems in terms of secondary means of escape. VS 992.
Yeah.
And that is what we have. Second question was to do with in terms of the details, we've got the holding down bolts. And then we seem to concrete them in.
Mm.
So when you actually come to the commission, how easy is that going to be in terms of acid joints? They detected in any way, or is it easy by demolishing that structure?
The bolts themselves are ground fully in.
Yes.
So you can't see the bolt down. Well, decommissioning and then obviously break out. Either slice them off, the rope saw. The hole was still in the top. Couldn't converse that.
There's always local work skills of fall.
As you know,
the holding down bolts.
Demolition nowadays is a big machine with gravel.
Questions? Please come on back. Can you repeat the question and refer? That's a question about the concrete pumping between the sleepers. Yeah, that's it. Yeah, first time I've seen that.
So originally the idea was to have a footbridge over the canal and then have a similar system just run this over the canal, but it ended up being a better process for everyone, as well as Canals River Trust and environmentally to have it with the way we did it and the way we put it.
So that's the first time I've ever seen that concrete being pumped between the sleepers. Kind of, yeah, not as you say, not a UTX. It's, I mean, how did you get that agreed with everyone, Network Rail as well, obviously?
Yeah. It went through the assurance process, Form 2.3, temporary works.
Yeah. That's fantastic.
You've got a pipe that put your pump through, it's less of a problem. Try and do it without that pipe. The problem is that there's a lot of fractures. Concrete screws, fractures, they're actually got encased with a pipe, so it protects the water. And
there's no issues there with the track support zone or the ballast
no,
between the sleepers.
So that's what you have it out there.
Fantastic, that's a really good solution. Saved a lot of time. Right?
You do.
Generally.
Generally, issue connections. In the design and build process, how did you build in sustainability? Or like how did you basically that?
Sort of a similar thing to what we covered before. In terms of the, I don't know if you've got anyone on this in terms of some of the specifics we did, but it's something that we've looked at through. I think it was very similar to. But was there anything in particular you were sort of wanting to really?
I mean, it's a very complicated structure. As you know, it's a very carbon-intensive material. One of the things with regards to lighting and ventilation within the station itself, even operational use.
But yeah, you can't work with it.
You've got photovoltaic on the roof. You use brick systems, and you use materials.
Their facility also wasn't within a quarry, so there's no transport of aggregates, etc. over on this.
I've got a question actually. It's not a controversial one, but how much did architecture lead the design of the station? Did you sort of have any kind of interface with that from the civil engineers and the structural designers back?
We did. I mean, it was very much a lead, as you can see in this sort of concept that we came up with. So I think the architectural steer really, because one of the early things behind this project in particular, and behind this station, was the university really wanting this station and everything, this actually to be something that was very much a gateway and an architectural design that would fit in with everything that it was in that sort of life sciences centre and things. So we very much led from the actual concept, and they are the guys that we worked very closely with in terms of trying to make that vision work and trying to make sure that the whole time as we collaborate on these things, I mean, we have sort of contact with the architects almost daily on this. We had so yeah, it was very
So was the
very much
architectural-
collaborative on that. Yeah.
So was the architectural concept kind of determined at what group 3, maybe group
Yeah,
4?
it's sort of in that first bit I looked at. So it was something that I believe was grid 3 when this was developed at the option stage, and then again taken through to a concept at grid 4, and then eventually, as you can see, I think that was a lot of what was sort of covered earlier, and you could see that when we did that sort of that early stage, and it is actually something that's driven right the way through, and that we have actually ended up with something that's very, very, very close to that vision, and yeah, I think it was successful on that front. I hope you agree, Warren.
It doesn't give the architect in the room the chance to speak on that.
And yeah, we were tasked with three. Second is
Thank you. Are there any other final questions? I'm just looking down online. Don't seem to have got any online ones today. So people in the audience are brave. But any final ones? If not, then we'll wrap up. I think it really just falls to me just to really thank our speakers for giving up their time to come today. Fascinating set of talks right through from the start. How you develop the design, the problems you've overcome. And it's quite awe-inspiring, really, the number of challenges you face. And particularly having had the chance to walk around the site this afternoon, see it's really a fantastic project. This is what we need more of in this country. We want to actually reduce our carbon input impact, and if we want to reduce pollution in cities. So it's fantastic that this is being done here in Birmingham, a really worthwhile project. I think without further ado, we'll just thank the speakers in the usual way. And thank you very much, everyone. As I say, we'll be back on the 30th of June for a talk on the Cycling Metro Depot. So look out for details on that. It will be online as well as in person. So we'll be in touch on that. Many thanks.